Hello and welcome to the webinar on test preparation and concept overview. My name is Pat Dunn and I'm a peer mentor in the Biostatistics 6125 and 8125 courses. In today's webinar, we're going to discuss concepts of interpretation, the odds and risk ratios, a 2x2 contingency table, graphs, cumulative incidence density, and prevalence. Finally, we'll talk about keys to course success and taking quizzes and tests. The class guide is a good model for what you should report in your interpretation for the application. It's a good rule of thumb is to always follow the step-by-step guide, watch the videos in the resources center, and of course read the text, the assigned readings. You should include analysis and explanation of your data sample, including what is typical and what is a deviation from the norm, how widely the data varies in their measurement, how the data is distributed in relation to other variables being measured, and finally, have you found a statistically significant relationship? The odds ratio and risk ratio are very similar. The odds ratio is the odds of exposure in a disease group divided by the odds exposure in the non-disease group, while the risk ratio is the ratio of the risk in the exposed group to the risk in the unexposed group. Both of these use 2x2 tables. So let's take a closer look. 2x2 contingency tables are used to compare data between two groups. So you have column 1, which is data from group 1, and column 2, which is the data from group 2. Row 1 are the positive outcomes, while row 2 are the negative outcomes. And of course you add up the sums of each of the rows and columns to perform your calculations. In the step-by-step guide from week 3, we have an example of an odds ratio. So we have cases and controls. The exposed cases are A, the exposed controls are B, the non-exposed cases are C, and the non-exposed controls are D. Okay, so to use that in an actual example here, in this example we have the existence of cancer and whether they were exposed or not exposed to tobacco. So we have 40 cases that were exposed and 10 cases that were not exposed. In the controls we have 29 yes and 21 no. So we add up the rows. 40 plus 29 gives us 69, 10 plus 21 gives us 31, 40 plus 10 gives us 50, and 29 plus 21 gives us 50. So we have 50 cases and 50 controls. So to calculate the odds ratio, we have A divided by B divided by C divided by D. So the A is the 40 and the B is the 29. So 40 divided by 29. C is 10 and D is 21. So 10 divided by 21. So the result of that is an odds ratio of 2.897. The risk ratio, or relative risk, is very similar to the odds ratio. The only difference is the math, really. The table is set up exactly the same. But instead of A divided by B, it's A divided by the sum of A plus B. And that is divided by C divided by the sum of C plus D. So in our table, which we just viewed, using this exact same table here, our calculation then is 40 divided by 69 over 10 divided by 31, giving us a risk ratio of 1.8. So as you can see in this table, the odds and the ratio and the risk ratio, a lot of it, the difference is just how they're used. Odds ratios are used for case control studies. Risk ratios are used for cohort studies. In an odds ratio, we're focusing on the exposure of interest, while as in the risk ratio, we're focused on the disease of interest. The odds ratio is best used when the exposure is more common, and the relative risk is when the exposure is rare and the disease is more common. So the bottom of this table again just reviews the formulas, all using the 2x2 contingency table. Now let's take a look at how graphs can help us understand and interpret the data. There's different types of graphs to choose from. Scatter plots are used to look at the relationship between two factors. You can kind of see trend lines, positive, negative, or no correlations. We have box plots, and those are helpful for identifying outliers, comparing different data sets. There's more information in the Week 2 PowerPoint on graphs. We have histograms, which are used for displaying continuous data in columns, and bar graphs, which display data in separate columns, and they can be used for continuous as well as discrete data sets. So let's take a look at how these graphs can be produced using SPSS. I have a data set open here. Select Graphs, Legacy Dialogues. Let's start with the bar chart. Select Bar. In this case, we're going to select a simple bar chart. Summary for groups of cases. Select Define. I already have the income variable selected as the category. Access. If it's not in the tray, you select from the tray. Add. And hit OK. And we have a bar chart. Next, we are going to select a box plot, Graphs, Legacy Dialogues, box plot. We're going to do a simple box plot. Define, I have age in the variable and income in the category. Select OK. And we have a box plot. And as you can see, we have a median in the middle. We have the 75th and 25th percentile in the box, and then we have our minimum and maximum for each of the variables. Now we'll do a scatter diagram, graphs, legacy dialogues, scatter, simple scatter, define, and I have age and income as my y and x variables. And here's my output for the scatter diagram. And finally, we will do a histogram, graphs, legacy dialogues, histogram. We're going to do this with age. And as you can see, we have a histogram. All of the bars are connected because we have a continuous variable with age. So now let's take a look at cumulative incidence, incidence density, and prevalence. With cumulative incidence, it's the total number of new cases within a specific period of time, and we do include death cases in cumulative incidence, but we don't include it in prevalence. So for cumulative incidence, we have the number of new cases divided by the total number that are at risk. With person time, it's an estimate of the actual time at risk, and we can do this in years, months, even down to the days that are the persons contributed to a study. Incidence is the frequency of new occurrences during the study period. The rate then is the number of new cases over a given period of time. So the incidence density is the number of new events per person time, and we're going to show an example of that in a minute. So prevalence is the total number of persons in a defined population with a specific disease or injury. A good example would be heart attacks and heart disease. So the total number of heart attacks in a year would be the incidence. The total number of people living who have experienced a heart attack would be the prevalence. So let's go back to the week 3 step-by-step guide to see how these calculations work. So in this example, we have a 2-year study of 200 people, and we're going to look to see who develops diabetes. At the end of the 2 years, there's only 160 people left. In year 1, 10 people develop diabetes. In year 2, 12 people develop diabetes. So first, to calculate the prevalence. So at the end of year 1, we had 10 people out of 200, so that gives us a prevalence rate of 5%. At the end of year 2, we had the 10 people from year 1 plus the 12 people from year 2, and we only had 160 left at the end of the study. So the prevalence rate at the end of year 2 is 13.75%. To look at the cumulative incidence at the end of year 1, again, we're going to find 10 cases out of 200, giving us a cumulative incidence of 5% at the end of year 1. However, in year 2, we have to subtract the 10 people that developed diabetes in year 1. So our denominator is going to be different in year 2. We're looking at the 200 minus the 190. So the cumulative incidence at the end of year 2 is the 12 new cases in year 2 divided by the 190 cases, giving us a cumulative incidence of 6.3%. For incidence density, we have to also factor in when these people were diagnosed. So in year 1, we know that 190 people were never diagnosed with diabetes, but 4 people were diagnosed in the first quarter, 2 in the second quarter, and 4 in the third quarter. So we have to factor that in with incidence density. So because 1 quarter is 0.25 times in a year, you take the number diagnosed multiplied by the fraction here. So 4 times 0.25 gives us 1. For the second quarter, we had 2 individuals, and it's 0.5 of a year. So 2 times 0.5 also gives us 1. In the third quarter, we had 4 individuals, and it's 4 multiplied by 0.75, which gives us 3. So our total number diagnosed is 4 plus 2 plus 4 equals 10, but our total person years is 1 plus 1 plus 3, giving us 5. We have to add the 5 to the 190 to give us our year 1 incidence density of 10 new cases divided by 195 person time years. And again, it's the 190 plus the 5 person time years, and that gives us an incidence density in year 1 of 5.1%. We do the same calculation for the year 2 incidence density. So we had 150 people left at the end. 20 were diagnosed in quarter 1, so 20 times 0.25 equals 5. 8 in quarter 2, 8 times 0.5 gives us 4. 12 in quarter 3, so 12 times 0.75 giving us 9. So a total of 40 diagnosed or lost to follow-up, and a total of 18 person years. So this calculation is 150 plus the 18 person years, giving us 168. We had 12 new cases in year 2, so it's 12 divided by 168, giving us an incidence density in year 2 of 7.1%. So finally, some keys to class success. Start each week by reading the assigned readings. Also review the step-by-step guides and watch the videos. They can be very helpful especially in learning how to perform the calculations using SPSS. Understanding of the statistical and biostatistical concepts obviously is very important. If you are having trouble, we highly recommend seeking out assistance from the peer mentors. The quiz in week 3, you should practice the formula and concepts, understand the definitions, especially understanding the difference between incidence and prevalence. Read and understand all the course resources. You can also retake the quiz. I believe if you do the quiz by Thursday, you have an opportunity to retake the quiz, and we recommend that you do that. It's a tough quiz, but there are no tricks. Again, for the quiz itself, know and understand the concepts, know how to use SPSS, organize your step-by-step guides, the concepts, and the SPSS material. The quiz itself is open book. You don't need to memorize the formulas. Have them, quickly accessible to you. Use the PowerPoint from week 3 and the concepts in how to use SPSS. Finally, some resources to keep in mind are how to access the peer mentor appointments, and you can do so at waldonU.mywconline.net. You can also access the library guides, which are good resources also for the biostats courses.